Physics lecture number 6, falling objects. A falling object accelerates as it falls. A bowling ball dropped on your foot will hurt more if it's dropped from a greater height since it has more time to increase its speed. Whether you're dropping a bowling ball or a pebble, all falling objects near the surface of the Earth accelerate downward at a rate of 9.81 meters per second squared. Sometimes we use negative 9.81 meters per second squared. The negative sign indicates that the object is accelerating downward. For some problems it helps to use the negative sign in the calculation, and for others we don't need to use a negative sign. If an object is speeding up and doesn't change direction, we can use all positive numbers. We also use positive numbers if we use y equals 1/2 at squared or any form of v squared equals 2a delta y. And these two formulas are used when an object starts from rest or slows to a stop. Generally, we use a negative sign if the object slows down and or changes direction. Under these conditions, we use a negative sign on the acceleration unit. If the object is moving down, we use a negative sign for the velocity and for the displacement. So let's try a problem. From rest, a rock is dropped and falls for 3 seconds before hitting the ground. What is its velocity right before it hits the ground? Well, since the rock is falling, the acceleration implicitly is given to us as a 9.8 meters per second squared. So anytime you see a problem or an object where it says an object is dropped, implicitly they're telling you that the acceleration is 9.81 meters per second squared. All right. And since it's at rest, the initial velocity is 0. So a lot of times they won't say initial velocity is, but they'll say something like it's at rest. So the initial velocity is implicitly given as 0. All right. So this is an object that, it's maybe on a cliff or something, and starting at 0 velocity, it's dropped and it just goes straight down. So since it's starting from rest and it's going in a single direction and speeding up as it goes, we can use all positive numbers when we plug them into the formula. All right, so the formula we'll use is VF equals VI plus AT. Final velocity is going to be equal to the initial velocity. Well, it starts from rest, so it's 0, plus A, the rate at which it speeds up as it falls, is always going to be 9.81. And then it falls for a time period of 3 seconds. So 9.81 times 3 is going to give me 29.43, and then rounded to 2 significant figures will give us 29 meters per second downward. Now, if the problem asks for velocity, we need to give a direction. So to indicate that the object is moving downward, we would write negative 29 meters per second squared. Okay, because we're indicating that the object is moving downward, so we have to use a negative sign if they ask for velocity. We need a direction. We have to tell it whether it's going up or down. All right, let's see. Let's try another one. A flower pot slips off a windowsill and falls 42 meters. Find the velocity of the flower pot when it hits the ground and the time it takes to hit the ground. So implicitly, they're telling us once again that you're starting from rest. And anytime you're starting from rest, you can use a formula like this, assuming they also give you the other variables that you need. So we're starting from rest. It's, once again, falling in a single direction and speeding up as it falls, so we can use all positive numbers. So we'll use this formula, and anytime we use this formula, we can use all positive numbers, and we only use this formula when the initial velocity is 0. All right, so let's just plug the numbers in. Final velocity is 2 times a. Well, since it's falling, implicitly the acceleration is 9.81. And the change in distance, well, it's falling through a distance of 42 meters. So that's the distance. And then 2 times 9.81 is times 42 gives me 824. And then take the square root, and we get 29.706 or 28.7. Once again, it's saying find the velocity, so we have to indicate the direction. And what direction is it moving? Well, it's moving downward, so we write 28.7 meters per second downward. Or we could have written, negative 28.7 meters per second. That would have also worked too. All right, so what we're going to do is we found the velocity. Now we need to find the time. All right, so we found the first part. We found the velocity. Now we need to find the time it takes to travel this distance. So using this value, or this value, we're going to find the time. And the way we'll find the time is we'll use this formula again. VF equals VI plus AT. Once again, our object is just moving in a single direction and speeding up as it goes along, so we can just use all positive numbers. So we calculated the final velocity is 28.7. It starts from rest. The initial velocity is 0. And then acceleration is 9.81. And we're going to solve for t, the time it takes to travel this distance. So if you do the math, 28.7 divided by 9.81 gives me 2.925 or 2.93 seconds. So that's how long it takes the object to fall through this distance when it is at a height of 42 meters. All right. Now what happens to the velocity of an object if it's thrown straight up? And suppose you throw a basketball straight up with a upward initial velocity of 12 meters per second. As it moves up, gravity slows its rate of ascent by negative 9.81 meters per second squared. It eventually slows down to a velocity of 0 meters per second squared. Now at this point it's stopped moving up and it's reached its peak. Immediately afterward, the ball begins to descend and increases its downward speed at a rate of negative 9.81 meters per second squared. And if you catch the ball at the same height at which you threw it, the ball hits your hand with a final velocity of negative 12 meters per second. So here's a picture describing all that's going on. So you're throwing a ball in the air, and right when you let go of it, it's going upward at a velocity of 12 meters per second. And notice that this is a positive number. So you throw it in the air, you let go at this point, it goes up, 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 slows down, slows down, slows down, slows down, stops, and then reverses direction and starts coming down faster and faster and faster and faster. And then if you catch it at the level at which you threw it, the velocity is going to be equal but opposite. It'll also be going at a speed of 12 meters per second in the opposite direction, and that's why we put a negative sign there. Acceleration both up and down is negative 9.81. As it goes up, it slows down, it decelerates, which is acceleration in the opposite direction. When it reaches the peak, it reverses direction and comes down, and it increases its speed downward at this rate. And the time it takes for the baseball to go up is equal to the time it takes for it to fall back to its original position. Or the time going up is equal to the time going down. So here, we don't know how long it takes to go up, but let's say it takes 5 seconds for it to come up. Well, guess how long it takes for it to come back down? It would take 5 seconds to come back down. That's what we're going to figure out. We don't know what the time is, but the time it takes to come up and reach the peak is going to be equal to the time it takes for it to fall down and reach its original position. So let's try a problem. A baseball is tossed into the air with an initial upward velocity of 12 meters per second. It is then caught at the same height from which it was thrown. How long did it take to reach the peak? How much higher did it go? And what was the total time it spent in the air? So, how long did it take to reach the peak? So we want to know the time it takes to go up. And then how much higher did it go? We want to know what vertical distance did it cover when it went all the way up and reached the peak? And then what is the total time it spent in the air? So I guess we want to know both the time up and the time down. Going down. All right, so let's see if we can solve it. Well, going up, its initial velocity is 12, and when it reaches its peak, its velocity is 0. So we've got the picture right here. We let go, it goes up, 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 slows down, slows down, slows down, stops. So we can treat this as though this were the initial velocity and this were the final velocity. So we treat the velocity at the peak as the final velocity. If we do that, we can use this formula. So final velocity when it reaches the peak is 0. The initial velocity when we first threw it in the air and let go, the moment we let go, was going upward at this speed. And then the rate at which the velocity changes as it ascends is negative 9.81 times t. And notice that since the object slows down, we use negative 9.81, not positive 9.81. Anytime the object slows down or changes direction, we have to make sure our signs are correct. We have to figure out whether it's plus or minus. Okay, well anyway, if we're going to solve for t right here, just the 12 moves over to this side and becomes negative. Negative 12 divided by negative 9.8 is going to give me 1.223 or 1.2 seconds. So you divide both sides by negative 9.8. And you'll get t equals 1.22 seconds. So that answers the first part. The time it takes for it to go up is going to be 1.2 seconds? Yeah, 1.2 seconds. Okay, so it takes 1.2 seconds for the object to come up and reach the peak if you throw it with an initial speed of 12 meters per second. Now, since the object comes to a stop, we can use v squared equals 2a delta y to find the maximum change in height. And remember, for anytime we use these abbreviated formulas, we use a positive value for acceleration. This is a shortened version of another formula where it includes, the longer formula includes both VI and VF. This one only includes VI. Anytime you use the shortened formulas, you can use positive values. All right, so initial velocity is 12. From the picture, the initial velocity was 12. 2 times a, acceleration is 9.81, and I just wrote it as positive because the abbreviated formula, we can use positive values. And then we're going to solve for delta y. So 12 squared is 144. 2 times 9.81 is 19.62. And you divide both sides by 19.62. And you get 7.339 or 7.3 meters. So this height is 7.3 meters. So if you let go and it has an initial velocity of 12, it will reach a height of 7.3 meters before it comes to a stop. Now, since the time it spends going up equals the time it spends going down, the total time of the air would be total time going up times 2. So we figured out earlier that it takes 1.2 seconds for it to go from the bottom all the way up to the peak. So to find the total time up and down, we just multiply this number times 2. So 1.2 times 2 is 2.4 seconds, and there's your answer. And we could have found the total time this way. We could have used this formula and used the actual initial velocity and actual final velocity and paid attention to the signs. The final velocity, well, we know that it's going to be equal and opposite when you throw it up this way, and that's the initial velocity, positive 12 meters per second. So final velocity is 12, initial velocity is positive 12, final velocity is negative 12 because it's going down. Initial velocity is positive because it's going up. Acceleration is negative 9.81 because gravity pulls down on the object and slows it down. So if you solve for time in this particular fashion, you get the same answer. Move the 12 over to this side, you get negative 24. Negative 24 divided by negative 9.81. You'll be left with t, that's just a small t, and you get 2.44 or 2.4 seconds. Either way is a legitimate way of solving for the total time of the air. We'll be using this method for a future problem. So let's try this problem. A coin is tossed into the air and it moves up with an initial velocity of 6 meters per second. And if the coin started at a height of 2 meters above the floor, how long will it be in the air before it hits the floor? All right, so at this point right here, which is 2 meters above the ground, we throw an object into the air. And as it goes up, it slows down, slows down, slows down, stops, and reaches a velocity of 0. When we first let go of the coin, it's moving upward with a velocity of 6 meters per second. So when you let go, it goes 6 meters per second, then it slows down, stops, reaches 0, and then it reverses direction, comes down, and goes faster and faster and faster and faster, and then smacks into the ground at some higher final velocity. So what we want to know is, we want to know the total time it's in the air. How long does it take for it to go up and down? Now this one, you can't solve it the way we did this one because This one is going up and down equal distances, and that allows us to multiply it by 2. These are not equal distances, so we can't figure out the time going up and multiply it by 2. It's a different distance. This is a shorter distance than this one, so we have to use another method. All right. Well, let's see. The change in displacement is going to be -2. Why? Because you start 2 meters above the ground, and now you're at 0. All right, so the net change in distance is that you change the distance by 2 meters in the downward direction. So that's why it's -2 meters. That's why the delta y is -2. All right, so knowing these facts and knowing that it slows down and changes direction, which means we have to pay attention to our signs, let's see if we can solve this. All right, so the way we're going to do this is we're going to solve for VF, and then we're going to use this value to solve for the total time. So our object slows down and changes direction, so we need to put the correct sign, plus or minus, in front of the velocities, distance, and the acceleration. So we'll use this formula to solve for the final velocity. Final velocity, we don't know how fast it smacks into the ground. We do know that when we throw it into the air, it's moving upward with an initial velocity of 6. 2 times a, the rate at which the object is being slowed down as you toss it. Well, since it's a free-for-all problem, implicitly it's -9.81, negative sign because gravity pulls down. And then the change in distance, it goes down, -2 meters. All right, so solving for VF, we've got VF equals 6 squared is 36, 2 times 9.81 times -2. Negative times negative gives me a positive, so that all cancels and gives us a positive. We get 39.24. 36 plus 39.24 gives 75.24. And then take the square root, you'll get 8.674 meters per second downward, or -8.7. Again, velocity, you have to indicate direction. And in our picture, if I can find it, here it is. In our picture, when it smacks into the ground, it's traveling downward, so the velocity is going to be a negative value. So we write -8.7 meters per second. All right, so we're going to use this value now. VF is -8.7. VI, when we first tossed it into the air, it was going upward, so it's going to be +6. Acceleration implicitly is -9.81 times t. And then if we solve for t, well, let's see, subtract 6 from both sides, and you'll get -14.7 here, and you'll just get -9.81 here. Divide both sides by -9.81, and t equals -14.7 divided by -9.8, and then that'll give you 1.498, or 1.5 seconds in the air. Now, we could have also solved the problem with this formula and used the quadratic equation to solve for time. So this, I don't know, that's just something I think you should know. So let's go ahead and solve it this way using the quadratic equation. The change in distance is -2. The initial velocity is 6. And we have t. 1/2 acceleration is -9.81 t squared. Well, if you simplify this to get ourselves a nice quadratic equation, 1/2 times 9.8 is going to give me 4.9. Then you move things over. You'll end up with a quadratic equation like this: 4.9 t squared minus 6t minus 2 equals 0. To solve for t, you use the quadratic formula. Remember that from algebra? -b plus or minus the square root of b squared minus 4ac over 2a. So b is -6, right there. b squared, so that's -6 squared. 4ac, 4 times 4.9 times -2, right, all over 2a. That's going to be 2 times 4.9, right? So we take this and try and solve it. See on the next page. All right, so simplify all this. 6 squared is 36. This mess right here becomes 39.2. You work this out, you get 8.67. It's going to be 6 plus 8.67, because 6 minus 8.67 will give us a negative number, which wouldn't make sense for time. And then if you solve for time, you get the same answer, 1.496 or 1.5 seconds. So either way, you can either use two formulas or you can just use the quadratic equation and solve for it. For a PDF transcript of this lecture, go to www.richardlouis.com. This has been Physics Lecture number 6, Falling Objects.